Word problems. Oh geez, am I right? I believe this is the first time that you'll be actively creating variables on your own. Don't at me. Each word sentence is usually a separate math sentence. We should first go on record to say that how old is Xavier is what we're trying to figure out. We're trying to find out the unknown that is Xavier's age. So you can write off to the side and say something like X represents Xavier's age, and then Y represents Yvonne's age. We've determined what we're trying to find out and labeled those unknowns using variables. Now let's see if we can deduce what's going on in the problem. Xavier and his daughter Yvonne are at a family reunion together, catching up with some distant relatives. That is not a math sentence. It's just giving you context for what's going on in the problem, so we can just skip that. After talking about when Yvonne was a kid, she suddenly realized something and exclaimed, "Dad, don't you know that you are exactly twice my age right now?" Stop! That's a math sentence. It's in words, but we can translate that into a math sentence. So, Dad, don't you know that you, so Xavier, remember Xavier's age, is exactly twice my age right now. Once Xavier confirmed this, the relatives wanted to know their ages, but Yvonne instead said, "Well, if you add up our ages, the total is 78. Stop! This one's actually pretty easy. So it's just, if you add up our ages, the total is 78. Now, we have our system of... Oh, how old is Xavier? I mean, that we've determined that. Once we have our system in math form, we can actually start to solve it. Remember when I mentioned... that these problems will have units attached to them? Well, sometimes, as in this problem, both of the equations are in the same units, and they're both in age in years. Nerd Rage Elementary School, oh, I went there, is putting on a school play as a fundraiser. Yeah, we're not going to really need that. Again, just context for the problem. There's so many different moving parts in these problems. The first thing you need to center in on is what the variable is equal to. Now, if you're unsure about what it is, it's pretty much always going to be that last thing. Like, what are we trying to find? How many of each type of ticket was sold? Yeah, that's going to be our variable. So for the number of children's tickets, it'll be for C, C for children. Number A is for number of adult tickets sold. We've labeled our variables because you can't really just start putting variables in the problems without kind of defining what they are. I wouldn't even know how to start the problem myself, honestly. Tickets for adults are $6.50 each. Tickets for children under 2 years old are $5.25 each. 2 and under are free, no ticket required. We don't need that. That's kind of extraneous information. I'm not quite sure yet what to do with the $6.50 each, $5.25 each. I don't know. It just seems kind of weird and arbitrary. Let's move on with the problem. See if there's anything else I can do. The total number of tickets sold was 32. Stop. That can be an equation because we already have the total number of tickets sold for the child and the adult, and then that is equal to 32. And the amount of money gained from ticket sales. So I don't know how to set up the other side of this, the variable side of this, but I know that this is going to equal $190.50. Figuring out how to set up the rest of this problem is intrinsically linked with the units for this. I don't know if I've gone over this yet, but units are kind of an extra variable in its sense. Like, I can't add inches and centimeters together right away. I would need to convert one of them to the other. But if there's no conversion, like how old you are and the number of cups of flour you put into a cookie recipe, like those don't really they don't have anything that means anything between them. The units of each term in a math sentence need to match. And that's why it's so important to keep that in mind. Once you know that, it's so much easier to set up the problem because you know what's important. You know what needs to line up. The number of this item is often an overlooked but completely valid unit. The unit for this is number of tickets, the unit for this is number of tickets, and the unit for this is number of tickets. You can even write off to the side like the unit is number of tickets sold, I guess. Teachers don't really put an emphasis on using the units to help set up the problem, and I think that's kind of barbaric. What's the unit going to be for this bottom sentence here? It's going to be money, because that's what that says there, money. When you're learning math, you're just using kind of unitless numbers. Like sometimes you'll use like degrees when you're measuring angles and, you know, some other things, but most of the time you're not using units. You're just like x equals 4. For what? You know? In this problem, knowing that this unit is money is really going to help us out. Maybe I can do like that. Unit is money. I know that there's a lot of side notes. Like we have to determine what the variable is here, and then we have to determine what the unit is here. But it's not like we're just given a formula with a problem and we just do some algebra and wrap it around to spit out a unitless answer. Like here, not only are we creating the variables, but we also need to create two separate equations, each having their own units attached to them. But that's what happens when you are creating your own problem from a word problem like this. I feel like I'm overhyping how to set up the rest of this. So we can't just say like, okay, children are 525 and then this is 650 for the adults. We can't say that. This is definitely not a complete sentence. How much money did they make just off of the adult tickets? Through multiplication, you know, we have the number of tickets sold, which is unknown but defined by A. And then each one of those is $6.50. So that's the total amount. 650 times A. And then using the same argument, how much money did they make off of just the children's ticket sales? So we have 525 for each of the C tickets sold. Now that you have the idea of how to do it, try some of your own homework problems or example problems to kind of drill it into your head, these new techniques of not even doing math, but being a translator. Systems of inequalities. This really is just graphing the inequality lines and then seeing where the overlap is. That's it.